Jai Hind all. I am Samender Singh in the Department of Computer Science and Engineering. My college name is Ajay Kumar Garg Engineering College, Ghaziabad. I'm teaching DA in 5th semester. This is my subject name. This is subject code. I'm taking a topic that is in a unit number 1. Algorithm and analysis. This is the topic name. So these are my course outline. First, I I will discuss about the definition of algorithm, then key elements of algorithm. After that, we will discuss some example of algorithm, and in the last, we will discuss analysis of insertion sort algorithm, which is a very popular algorithm for sorting the given unsorted list. So, in the starting, we are discussing about what is algorithm. As a concept, it is a very common thing for doing any task we are assigned. So, as a definition, algorithm is a precise description of the process of solving a problem, a given problem, consisting of finite number of instructions which can be executed mechanically and produce a deterministic result. As we can say, for doing any task that is allotted to us, we need to solve that. We are using a number of steps, number of procedures, number of instructions for doing that. So these are 5 features if we have for doing any task that will treat the task, then the given procedure is known to be algorithm. These 5 features is first finiteness, then definiteness, then input, output, effectiveness. These are the 5 features that we should have for solving any given task. As a simple example, we need to discuss, just like we suppose we want to go college from our home. So we have number of paths for reaching home to college. Suppose this one C1, C2, these are our paths. So these are the n number of paths through which we can reach our college from home. So as a 5 features, we need to understand which path we should use for reaching our college. So this is our task. Task is what? Need to reach college. So we have input. Input means we have number of paths. Then output means we as you can see, we can reach in at college by means of these all paths. But what concern that make our task so efficient? So efficient in this particular example will be time. If we reach college on time, or we can say if we are reaching time, we are reaching college on minimum time, or we can say that the path should be so easy, better to us, we don't taking any harm for that. So these input and output we can understand by this one. Finiteness, we have to reach. So path we are choosing must ensure that we will reach our college. This is finiteness. Definiteness means we have a clear instructions, we have clear definitions of our path. And effectiveness, no need to do any hard work relative to our path. So this is now in the next things we are discussing about, that is philosophy of problem solving. So first, to deal with those which cannot be solved, we compromise. Suppose we have given a problem which can't be solved. In this particular things, we generally expecting a philosophically we thought we are compromised with that particular problem which are not going to solve. Second, to deal with those which can be solved means we know this problem is very easily solved. So we are trying our best, or we can say we choose best solution for doing that, for doing for solving that problem. And the third, to distinguish between the two classes, the above two classes, first and second case. In first, we have a problem with having nature cannot be solved, and second can be solved by number of solutions. We use our wit. These are the three philosophy that we are generally done for solving any given problem. Now, this is very, very important. That is algorithm and computer science. These two analogy or these two concepts generally need to discuss. First, the study of algorithm is more than a branch of a computer science. It is a central to all area of computer sciences. Means for every problem that we will discuss in our branch, or we can say computer science, concern center to our area, that is algorithm study, and in all the fairness can be said to be relevant to most of science, business and technology, particularly applicable to those disciplines that benefits from the use of computers, and these are fast becoming an overwhelming majority. This is first thing. Sometimes people ask, was really is computer science? Why don't we have telephone science? Telephone, it might be argued, are as important to modern life as computer are, perhaps even more so. A slightly more focused question is whether computer science is not covered by such classical discipline and mathematical, physics, electrical engineering, linguistic, logic, and philosophy. These are some basic things that we will concern with. We would do best not to pretend that we can answer these questions here and now. The hope, however, is that the course will implicitly convey something of the uniqueness and universally of the study of algorithm, and hence something of the importance of computer science as an autonomous field of study adapted from a spirit of the computing. This is algorithmic, the spirit of the computing. Now we have some criteria through which we analyze our given algorithm, or we invented new algorithm. For analyze that particular new invented algorithm, we have certain criteria. First, correctness. Is it correct to that particular solve example? And then amount of work done, amount of space used, simplicity, and optimality. These are five criteria through which we analyze our algorithm. So first we will discuss what is correctness. Describing the correctness, the specification of a specified problem. That is preconditions versus post conditions. Establishing the method, preconditions plus algorithm, that is post conditions. Or we can say we have a correct specified input that we call preconditions. Then on these input we are apply our algorithm, and then we are getting final output that we are searching for, or we can say solution of the problem. Then providing the correctness of the implementation of the algorithm. These are the things that define our correctness. That is the, in general language we can say, providing the correctness of implementation of the algorithm, or we can say how we solve the problem should be very correct, or instructions that we are using to solve any problem must be so correct so anyone can use that algorithm. And second, how to measure, that is not too general, that is giving some indication to make useful comparison for algorithm. As we can say, suppose we are inventing new algorithm of the given problem P. But this given problem may have many solutions, or we can say may have a number of algorithms through which it is solved. So we are measuring the this our algorithm, or we can say we are analyzing new invented algorithm by means of the given solutions, or we can say other algorithms. So these available algo, so we are analyzing our algo with respect to these given algorithm, or we can say this is how we measure our algorithm as far as our analysis is concerned. So these are not too precise, these are the things through which we can measure. That the first thing is machine independent, second language independent, programming style independent, or implementation independent. These are some scenario through which we are measure our new invented algorithm. Focusing the view, that is counting the number of passes through a loop while ignoring the size of loop. Then operations of the interest, just like search an array, always consider comparisons, then multiply two matrices. So here we are focusing on multiplication operation. Then we have sorting an array. So again comparison is focused on, comparison is the operation on which we are focusing. Then traversing a tree, this is also processing an A's, and non-iteration procedure produces invocations. These are some general problems we are focusing. So these are the general operations that needs to be focused. Now, presenting the analysis result, that is amount of work done usually depend on the size of input, that is size may be differ from each problem. Suppose we have a list which are going to sort, it may have number of items. In first case we have n1 number of items, then in second case we have n2 number of items. Then we have amount of work done usually does not depend on the size solely. We have complexity, we have number of complexity, just like best case complexity, worst case complexity, average case complexity. So first we are discussing about worst case complexity. So it is a specified algorithm A for a specified problem P of size n. So this is our problem P, algorithm is A and size is n. So given the maximum number of operations performed by A on any input of size n, being a function of n. So first we need to focus on the function of n on which we are doing some operations, then that is denoted by W, and that is worst case complexity. Since we have n number of items, or we can say n size list, so Wn will be maximum of Ti, time taken by each iteration. I belongs to D. D is the set of index. set of inputs. So these are the maximum time taken to solve or to sort the given list, if I am talking about a list that is going to sort it. So if we are taken maximum time, so this is our worst case scenario, or we can say worst case complexity. Compute the maximum time taken by the algorithm. Then we have second complexity, that is average complexity. So this is again we are focusing as a we are focused on average case scenario, in which we are consider the case in which we utilizing average time for solving the problem. Suppose this is an average case having n number of input. So again we are summation sign sigma. So this is I belongs to again number of inputs, where PRI means probability of I taking time Ti. How to get probability I? That is by experience simplifying assumptions on a particular applications. Let's take an example, that is sequential search. So as an input we have a array, that is unordered array. We have number of items in which with n entries, a key k that we want to search from the given list. So what is the output, or we can say what is our goal? Our goal is to find that particular key in the given list. Suppose after searching that element in the given list, what we have? The location of key in the array E. So there are two possibilities. Either we are getting that element in the given list, or we are not getting that element in the given list, or we can say second case is fail, or we can say we are not getting that key in the list. Or suppose if we are getting, that means in that particular case we have location of that. So procedure is, suppose this is pseudocode or algorithm for doing sequential search in the list. So in the sequential search in array int, and these are two other parameters. We have three parameters. First is array, unsorted array, then number of elements in the array, that is n, and third is k. K means location of that particular key that we are going to search in the given list. So as an initial point, we are defined two variables. First is answer. Answer contain the location of the key, and that second is index. So as a initial point, we assign this answer as a -1. Why -1? Since -1 is not a valid index of the given list. As we all know, starting index of the given list will be 0. So counting will start from 0 to n. So as an initial point, we assume or we initialize the variable answer to -1. Then we have iterations, for which we are using a loop, for loop, in which we have three things to define. First, index will be starting to 0, all know. Then index, how long it can run? It can run the maximum bound of the given list, that will be n. So it will remain less than n. This is second thing, and every time we need to update our index value. So for operating this for loop. So what conditions we need to discuss? That the k or key is equal to the E index. So first case, that is, suppose this is the list. Suppose this is 1, 2, 3, 13 and this is 12. Suppose this is list that we are searching for 4. So as an initial point, we have answer -1 after this one. So as an initial index is 0. So loop will start as, so if k, what is k here? K is 4. If it is E0 means 4 is equal to E0. E0 is what? E0 is starting first element 1. Since these are not equal to each other, so this is not updated. Then again we are iterating this loop. Next case is what? Now index value will be increased to 1, that is 1. So in this case, this is comparing with second element, that is 12 is be equating to 12 is compare with 4. In second case again we are not getting the appropriate answer. So again index updated to third value, that is 2. Again 13 is compared with 4. Since it is not equal, so again updating the value of index. In the fourth case, it is where when index having 3, it is equal to 4 and we are searching that element, that means 4 is equal to E3 array index 3. Index 3 is 0, 1, 2, 3. So this is equating. So we are getting our answer. That means answer will get the actual things, that is index, appropriate index. So we are getting, and break means we are returning this value. So this is how we are getting the appropriate position or index of the given key in the given list of array. So this is how we solve sequential search. So this is how we analyze the things. In this particular algorithm, we have number of comparisons. So as a first line, we have number of parameters which we are providing to solve the problem. Then in the second case, we are initiating or define some number of variables. In the third, we are assigned first, so we are taken constant time in second case. In the third, we can maximum iterating to this loop, that will be n times. In the same case, this is also n, this is n, and this is thing. So by considering all these things, then constant plus n plus n plus n, or we can say constant plus 3n. So as a complexity of this algorithm, we have n, or we can say linear approach, or we can say maximum or worst case analysis of this algorithm is linearly, that is n. Okay, in the next video we will discuss about the second topic. Okay, thank you all.